L equal the set, my pen's not writing very well, set of all strings over the alphabet A, B, C, D, that contain the substring BABA, like Baba Black Sheep. Okay, so let's just stick this up here so remember what we're trying to do, but I have a little bit more space. So we want the set of all strings over the alphabet A, B, C, D that contain the substring BABA. So just like when I'm trying to figure out what does a regular expression represent, and I look at I think about building up the strings. How can I build a string? I want to have a string. It definitely has to have BABA in it, right? So I'm going to start by writing BABA right in the middle there. And then I need to think about what could this string, a string that's in this set, what could it start with, right? So here's my set again, make it a little bit bigger. What could I have before that BABA that would still be in my string? And the answer is, as far as this language is concerned, I can have anything, right? So I can have any letters before I get to the BABA. I could have 0 letters or more. So I could have, I guess, anything, any string, A plus B plus C plus D star. And what happens, it's even possible that before I get to this particular BABA that I have more BABAs in there. That's fine. It doesn't say it has to contain it just once. It just says it has to contain that string somewhere in there. And what about afterwards? Well, afterwards, and I hope you'll forgive me for using different colors here, but it's just to kind of show you that how I'm sort of thinking about it in different segments. It can be any letter again, right? So now I've got a regular expression. Let me just write the whole thing out again. I've got A plus B plus C plus D star. So it can start with anything over the whole alphabet. Then I have this substring BABA, and then it can end with anything. And I'm using the concatenation operator, the squish, right? There's an implicit dot in here that I don't say, to say that these all things are squished together. And that gives me the set of all strings that have BABA in it as a substring. Okay, let's do something a little bit trickier. Let's have the set of all strings over the alphabet, same alphabet, A, B, C, D, that do not contain the substring BA. Okay, so they can't have any BAs in them. Okay, so let's see, can I squish? Yay, I can squish it. There you go. Okay, so I want to have the set of all strings that don't have a BA in there. So let's think about that. I want to build up a bunch of strings, right? And it's an infinite set, so I'm almost certainly going to have a star there, right? And I want to combine anything together that doesn't have the substring BA. So for sure I can have as many C's as I want, as many D's as I want. And the catch is, how do I deal with that BA thing, right? And in truth, I think what I can do is the following. I can say, well, I could really have as many A's as I want, right? It's just if I have a B, I got to be careful. So if I have a B, I can have as many B's as I want as long as they don't end with an A. It has to end with a C or a D. So I'm going to say, and I could also choose a bunch of B's as long as it ends with a C, or a bunch of B's as long as it's followed by a D. And so this is fine. Any string that I build up from here is never going to have a B with an A immediately after it, because every B that I put in there has a C after it or a D after it. Now, I didn't actually notice this immediately when I came up with this. I came up with this example on the fly in class, but one of my students pointed out that, in fact, this little piece, B star C, includes just a plain old C without any B's in it. And similarly, this B star D includes just a D without any B's in it. So a slightly simpler way to write this regular expression, which is exactly the same language, is A plus B star C plus B star D, quantity starred, right? So it's any string that's made up of the letter A, or a bunch of B's followed by a C, or a bunch of B's followed by a D. Oops. The one thing that this language can't do right now that I've missed out is it can't end with a B, right? None of my strings can end with a B right now because I'm so worried that I'm going to have that, I'm going to have an A after it that I sort of forgot about ending with a B. So in order to make this actually that set, I have to stick a B star at the very end and say, if I want, I can put as many B's as I want after I've got all the rest of this stuff, right? So there's that one. And now let's just do one more, which is, suppose that I want to have the set of all strings that have exactly one copy of the substring BA. Now we need to think a little bit, because here, let's squish this up here and put it up there. There's my set of all strings that don't contain BA. Now what I want to do is the set of all strings over the alphabet, same alphabet, A, B, C, D, that contain the substring BA exactly once. Okay? So that's what I'm working on now. Okay? And this is sort of a combination of some of the previous stuff that we've done, right? Because I know it's got to have a BA in it, but it can't have a BA before it, and it can't have a BA after it. But we're super lucky because we know that if we want the language that doesn't have any BAs before it, we could just stuff this thing in. And similarly, if we don't want any BAs after it, we're okay. We can stick this thing in, right? So, in fact, I think, let's see if I can write it small enough in here. A plus B star C plus B star D, followed by as many B's as I want, and then BA, and then the same thing at the end. A plus B star C plus B star D, and then as many B's as I want at the end. Okay? And that represents this thing. That, ooh, wait, all my blue ones are the same size. It's growing. Okay, forget it. That represents that, right? All the substrings over the alphabet, all the strings over the alphabet, A, B, C, D, that contain exactly the substring BA exactly one time, okay? And just one more thing to note about regular expressions. Remember that when we were talking about sets and we talked about like the language A, B, C, and we said you can star a set, right? And we said that's 0 or, right? So that's 0 or more occurrences of the things in this set, right? And when we were talking about sets, we also said you could do like A, B, C, and you could plus that set, right? We said the plus was 1 or more, right? And the big difference here was that if there was no lambda in this set, then our plus of that set doesn't contain lambda, whereas the star of that set does. Now here's the big warning, right? And now I have to shrink it to make some room, but you'll remember it's a big warning, right? When you're talking about regular expressions, right, you can talk about, ooh, wrong thing. I want to use the pen there, sorry. You can talk about A star, that's totally fine. You can talk about A plus B star, whatever, right? But you cannot talk about A plus. There is no A plus in regular expressions. You can't talk about A plus B with a superscript plus, right? You can't do that. The only pluses in regular expressions are the pluses that mean union, right? Okay, that's it.